All right, this is going to be the second part of Notes 13, and we are going to start factoring some trinomials. Trinomials, simply something that has 1, 2, 3 terms in it. That's what makes a trinomial. All right. Now, the part that we're going to deal with today is everything in this question set. So A through G, everything's positive. All right. First thing I want you to think about is, do you have a GCF? And I'm always going to ask you that question first when you are dealing with factoring. And the reality is in part A, no, you don't have a GCF. So we have this trinomial. Our x squared term is first here. We are going to split it. 1x in each of our little factors. Because what's going to happen here is when we go to multiply this, x times x is going to create that x squared term. All right, love that. Now, how else do we deal with this? Well, I need to think of two numbers that, oops, let me actually get something that's writing here. There we go. Multiply. Okay, we want to multiply to 6, positive 6. I already said everything's positive. And I want those same two numbers to add up to positive 5. Well, if you think about what multiplies to 6, all right, we don't have too many options. We have 1 times 6 and 2 times 3. Well, I don't care what you do with it. Well, no, actually, I do care what you do with a 1 and a 6. Here's the problem. The 1 and a 6, you might say, oh, well, if I subtract, 6 minus 1 is going to get me 5. The problem is then not everything's positive. So I don't want to use 1 and 6, but I can use positive 2 and positive 3. Here's your quick check. If you take 2 times 3, that absolutely creates the 6. And then your inside and your outside terms, and actually I'll write this out here. So if I do 2 times x, that's 2x. If I do x times 3, that's 3x. Everything's positive. That's that 5x that we were looking for in the middle. So what are your actual factors here? Let me grab a highlighter so I can actually highlight my answer. My answer is those two factors right there, x plus 2, x plus 3. Now, the check that I actually showed here, most of the time, 99.9% of the time, I'm just going to do it in my head. Okay, but that's part A. We've got our factors. Let us move on to part B here. Do you have a GCF? No, I don't care what you do. You're like, oh, we've got x's in the first two terms. You don't have an x in the third term. 8 and 15, yeah, there's nothing that's going to divide into both 8 and 15. So let's go ahead and take our x squared term. We're going to split it. We're going to add to positive 8 and multiply to 15. So let's see, what multiplies to 15? 1 times 15. Let's see, 3 times 5. There's your pair of factors here. So plus 3, plus 5. The order that you write those answers is absolutely irrelevant. So if on your paper you put down x plus 5 and then x plus 3, these are the exact same answer because, well, the order of multiplication does not matter. All right. Keeping on moving on here, part C here. I'm going to shorten it up, so it's going to be M for multiply, A for add. Oh, wait a minute. Before I do that, do you have a GCF? No? Okay, cool. So A for addition, M for multiply. And let's see. X squared is going to be x squared. We're going to split that. So things that multiply to 8. 1 times 8, 2 times, hey there, 2 times 4. So positive 2, positive 4. If I do my quick check, 2 times 4 gets me 8, and then 2 plus 4 gets me the 6. I guarantee you those are your right factors. Do you have to write these off to the side? Absolutely not. If it helps you, then do it. All right, especially if you get into some hard, I'm not going to say harder numbers, but numbers that have more factor pairs, sometimes it's a little bit more complicated to figure it out. All right, GCF for all three? No. All right, no GCF. Then we're going to take our x squared, we're going to split it. We got a trinomial here that we are trying to multiply to 21. So 1 times 21, 3 times 7. And I'm looking to add up to 10. That's going to be the 3 and the 7. So plus 7 plus 3. Again, order doesn't matter. All right, at some point, the signs are going to matter a lot more, so we'll have to pay attention to those. All right, so that's the top set here. Sliding down to the second row here, we've got part E. Do we have a GCF? Absolutely not. So let's go ahead and split the x squared term, right? X and x. I'm looking to multiply to 12. So 1 times 12, 2 times 6, 3 times 4, and I want to add up to 7. There's the 3 and 4. So plus 3, plus 4. Again, order is never going to matter with the actual factors. So if you had x plus 4 first, awesome. You have the right answer. All right, part F. Do you have a GCF? Absolutely not, because the GCF has to be from all 3 terms, not 2 of them. Because you might say, oh, we've got x here and x here. Great, you don't have an x here. Oh, but these are divisible by 9. Awesome, that one's not. So no GCF. All right, but we can factor this as a trinomial. So split the x squared term. And then I'm looking to multiply to 18. So let's see what we got here. 1 times 18, 2 times 9, and 3 times 6. And out of those 3 factor pairs, I want to find the one that adds up to 9. And that's going to be 3 and 6. So plus 3 plus 6. If I do a quick check here, x times x, x squared. 3 times 6 is 18. 3x and 6x make the 9x in the middle. Because everything's positive, that's a pretty quick check that you can do. All right, last one on the page is going to be part G, and that will then end the video. So this is going to be, do you have a GCF? No, for all the same reasons that we've talked about. Nothing is common to all 3 terms. So split the x, looking to multiply to 20 and add up to 12. So things that multiply to 20, 1 times 20, 2 times 10. I'm going to stop right there. Yes, I know there are other things that multiply to 20, but if you find the right values, you found the right values. So let's go with a plus 2 plus 10. Quick check to make sure it works. X times x, x squared. 2 times 10 is, there's my 20. 2x plus 10x, that's the 12x. Everything worked out great. We have factored. All right, so that's the end of this set for Notes 13. As always, let me know if you have any questions or concerns, and I'll see you back in the next one.